Hello everyone, you're welcome to another math class. Today in our math lesson, we'll be looking at addition and subtraction of decimal numbers. Addition and subtraction of decimal numbers. In our earlier lesson, remember we talked about decimal numbers and we said that decimal numbers are those numbers that are a combination of whole numbers and fractions. A combination of whole numbers and fractions. And we said that the whole numbers are usually separated from the fractions with a decimal point. For instance, you have a number like this, 16.5. The 16 here is the whole number, is whole, complete, but this 5 is a fraction, it's not up to 1, so this is a fraction. Now in the middle you have a point. This point is called the decimal point. The decimal point, and this is usually what separates the whole number from the fraction. So a number like this is a decimal number. And there's another example I would like to quickly show us. Like if you have 20, you have this kind of number. Now if you want to call this kind of number, this is also a fraction, remember, because there's a decimal point here. So this first two digits, this 20 is 20, is whole, but this 1 and 5 is not complete, it's not up to 1. This is a fraction. So if you want to call a number like this, you can't say 20.15. No, because this 15 here is not 15. It's a fraction, it's not up to 1. So you say 20.15. That's how you call such numbers, 20.15. Okay, so just trying to refresh our memories on decimal. So, but today what we will be looking at is the addition of numbers like this. First, we look at the ones without regrouping. And after we're done with that, we go to the ones we're regrouping. But let me quickly state that the addition and subtraction of these numbers is basically the same thing as addition and subtraction of normal numbers. And by normal numbers, I mean whole numbers. It's basically the same thing. The only thing you need to take note of is your point. And you have to ensure that the numbers you are adding or subtracting, when you arrange them, the points always align. The points should align. Because if the points do not align, then you're definitely not going to get the right answer. That's the only thing you need to be aware of, okay? Otherwise, it's simply just the normal addition and subtraction of numbers. So let's take some examples. So the first example we're going to look at is what we have right here on the board. 24.15 plus 15.72. So those are the numbers we are adding. We try to add them. So now look at the way they are arranged. Okay, so you have 24.15 and then 15. Arrange the way we normally arrange when we are adding numbers. Okay, so, but one thing I need you to take note of is the alignment of the decimal points. You can see that they are sitting on the same line. This is what has to be put into, you must put this into consideration, okay, whenever you are arranging decimal numbers for addition or for subtraction. Okay, so let's go on and add. 5 plus 2, that gives us 7. 1 plus 7, that gives us 8. And then you bring down your points. Okay? 4 plus 5, that's 9. And 2 plus 1, that gives us 3. So our answer is 39.87. So you see that's exactly the same way you add your regular numbers. The only difference is the presence of the decimal points. Okay? So let's take a second example. So the second example we're going to look at is 42.05 plus 16.83. Okay, so let's add. You have 5 plus 3, 8. 0 plus 8 is 8. Again, your point. And then 2 plus 6, 8. And 4 plus 1, 5. Simple and straightforward, right? So I'll quickly show us one example in this category that is a little bit not so straightforward before we move on to addition with regrouping. Okay, so here is the last example we're going to consider in this group without regrouping. But then this is a peculiar example, and I'll tell you why. If you look at the numbers, unlike the first two examples we took, we had the same amount, the same number of digits to the left and to the right of each of the numbers, to the left of the decimal point and to the right of the decimal point. We had two digits each on both sides, the first number and the second number. So to arrange them was something very easy, and automatically the points, would just align. But in this case, if you look at the first number, you have 2 digits to the left, 1 digit to the right. Whereas in the case of the second number, you have just 1 digit to the left and 2 digits to the right. Now you are not going to arrange them and say and think it's the same way. It's not business as usual. You cannot arrange like this, because maybe you think after all they are both 3 digits in all, and you arrange like this. That will mean this first point will be here and the second number we have is point here. You see, the points are not in the same place. The points are not aligned, and there is no way your answer can be correct. This is very wrong. Okay, you don't arrange that way. So regardless of how the numbers are, how many digits you have in each number, the thing you need to take note of is that the 2 points, when you arrange your numbers for addition, the 2 points must align. Your point is what determines where each digit stays or where what digit stays. So this is what determines it. At any point, the digits must be in alignment. They must stay on the same line. So you see here, we wrote 15.4, and then the 3 now comes here because the point needs to still come under this point here, and then you have your 15 to the other side. Now I will explain why it's this way. I remember we said earlier that the numbers to the right of the point, they are fractions. This 15 is fraction, this 4 is fraction. So fractions have to stay anyhow to the right side of the decimal point. And then we told you that the numbers to the left are whole numbers. So 15 is whole number, 3 here is whole number. So you have whole numbers to one side of the decimal point while the fractions stay on the other side. So that's why it's very important for the points to align. Fractions stay together, whole numbers stay together, okay? So when you want to add, if you like, you can put 0 here. You can add 0 to the 4 just to make it look balanced, okay? But it doesn't really matter if you don't add it. So let's add 5 plus 0 is 5, 4 plus 1 is 5. You put your decimal point. You always remember that. It has to be there. And then you have 5 plus 3, 8, and 1 plus nothing is 1. So this is your answer, 18.55. Okay, so let's move on to with regrouping now. So the next example we're going to look at is that of addition with regrouping. So we have an example here on the board. So let's quickly walk through this. 8 plus 4. We know that 8 plus 4 is 12, but we can't put 12 down here. So we write down 2 and we bring the 1 here. Okay? We transfer the 1 to the other end, and then we have 1 plus 2, 3 plus 4, that gives us 7. And then your decimal point. 6 plus 3, that's 9, and 1 plus 3, that gives us 4. Okay, so you see the regrouping we did here now. When you add and you have more than a single digit as your result or answer, you need to move the tens, the one that is apparently or supposedly in the tens position, move it to the next column. You write down the one in the unit position, okay, and you add. Now, if for any reason you add again and you have another 2 digits here, pull down the number still in the unit position and move the ones across the point, okay? I don't want to start explaining all the reasons behind everything, but just note that you can't have 2 digits in a certain column. So you always write down the one in the unit position and you move the other one in the tens position. Okay, so let's take a second example. So let's look at this example with the second example here. So these are example 2. 2 plus 7, that gives us 9. So we write down our 9. 6 plus 4. 6 plus 4 gives us 10. but we know we can't put 2 digits down here. So what do? We pick the one in the unit position, we write it down, and we move this one across the point to the other side, okay? Because this actually means a whole. Now this 10, when you have 10 in this position, just immediately after the point, it has gotten to a whole number. So it's one whole number, 0 units, 0 in the decimal position or 0 fraction. So that 0 will remain here, while the 1 will now move to the position of whole, because once it's up to 10, it has become whole. So that's why this one can come now, be transferred to this position. So 1 plus 8 is 9, and 9 plus 9 is 18. Again, we cannot write 18 here. So what do? We write down 8, and we move that one to the other end, just like we do in our normal addition of whole numbers. So 1 plus 2 is 3, plus 1 is 4. Okay, so you see in this case, the second case, we had number more than 1 digit, like 10, so we couldn't put that there, and then the number in the tens position had to move across the decimal point to the other side. So here we have 48.09. So it's basically the same thing. The only thing you just keep taking note of is your decimal point. Okay, so now we're going to quickly look at subtraction with so our first example in subtraction without regrouping is what we have right here, 84.26 minus 63.04. So again, you see the arrangement just like we arranged when we were doing addition. The only difference here is we are subtracting. So 6 minus 4, that gives us 2, right? 2 minus 0, that's 2. And then you remember to bring down your points. 4 take away 3 is 1, and 8 take away 6 is 2. So our answer is 21.22. Okay, 21.22. So let's take another example. So we have 56.75 take away 23.25. Okay, so 5 take away 5 is 0. 7 take away 2 is 5. Again, your decimal point. 6 minus 3 is 3, and 5 take away 2 is 3. So our answer is 33.50. You will see how straightforward this is, okay? Yeah, it's straightforward. So I think we should just move on to subtraction with regrouping. That's where we need to case straightening. So next we're going to look at some examples of subtraction of decimal numbers with regrouping. Again, it's exactly the way it occurs in normal numbers. So let's take a look. Here we have 5 take away 9. We know that 9 is bigger than 5, so it's not going to work. What do? We go to the next number and we borrow 1. So when we take 1 from here, the one we bring it here. Remember, the one we're borrowing from here has the value of 10, okay? So that's why our number is called the decimal system. It's a decimal number system. Whatever you borrow in this system is like 10. Okay, so the one you bring here, add it to this 5. This 5 plus 10 becomes 15. So you can now take away this 9 from 15. So 15 take away 9, that gives us 6. Now remember, you took 1 from 8, so our 8 is now remaining 7. So 7 minus 6, you have 1. Again, you bring down your decimal point. So 3 minus 2, that's 1, and 7 minus 6, that is 1. So our answer is 11.16. 11.16. So let's take one more example, and I think we should be okay. Okay, so this is the last example we're going to look at. So you have 28.8 minus 15.74. Somebody may say, oh, this one has more digits. How can we take it away from this? Remember, I told you that the numbers before the point, those are the whole numbers. It's the whole one, while the one after is decimal. So if you want to consider which number is actually bigger here, just look at the number, what we have before the point. So 28 is bigger than 15. That means this number is bigger than this number, regardless of the number of digits that the second number has. So as usual, we're going to arrange and make sure that our decimal points, they align together. If you look at this place now, it's empty. It looks strange or a kind of odd, right? But it doesn't really matter. What matters in decimal number addition or subtraction is the arrangement of the numbers to ensure that the points always align. Okay, so you ask, how can we subtract 4 from nothing? That is math. Nothing in mathematics means what? 0. So add your 0. That's what nothing means in maths, right? So what do we do? 4 from 0. Can we subtract 4 from nothing? No. So as usual, we will come to 8 and borrow 1 and bring it here. So this number now becomes what? 10. 10 take away 4, we have 6. Now because we took 1 from here, this place remains 7. So 7 minus 7, we have 0. Again, remember to bring down your points. So 8 minus 5 is 3, and 2 minus 1 is 1. I hope it's clear. So don't let this bug you. This was an empty space, so we just put 0 there so that there will be a reflection of a digit. Okay, so put 0 there, and yet we know we can't take away 4 from 0. So you come to the next number, borrow 1 and bring it here. This 0 becomes 10 because any 1 you borrow in the decimal unit system is 10. So 10 plus 0 is 10. So 10 take away 4 gives you 6. Now this is remaining 7. 7 take away 7 is 0. Just like that. Okay, so I hope we have learned something today about addition and subtraction of decimal numbers. If you still are not so clear, you can play the video again, watch it over and over until, because it's something I know you will get. Okay, maybe you watch it thrice, and try your hands on some questions. Okay, so until next week, stay safe and stay blessed.